With the dams out, water is going to move through the system in a more natural regime. The sediment is going to be able to move through the system in a more natural regime. The dissolved oxygen is going to be improved. The temperature is going to be more natural. We expect water quality to be really improved by the project. Okay, we can maybe cross and go up there to like those willows. Oh, look at that gravel.
There's gonna be fish spawning up here.
My name is Caitlin Boyce, and I am an aquatic ecologist with RES. And for the purposes of the Klamath project, I am the water quality technical lead. So that means that I'm overseeing the whole kind of water quality monitoring for the project, from all the way up at the Kino Dam and then down to the estuary where the Klamath meets the Pacific Ocean. This work is really important because we're documenting a change from the dams in condition to a dams out condition. We're doing a bunch of different types of monitoring. We have stations set up that are collecting data in 15-minute intervals. We're also out collecting sediment samples as well. For this work, RES is partnering with the Karuk and the Yurok tribes. They are out every month at sites in the estuary of the Klamath, near Orleans, near Syad Valley, below Iron Gate, below Copco, and then kind of up into Oregon near J.C. Boyle and Kino as well.
We're at Daggett Bridge, which used to be the upper extent of Iron Gate Reservoir.
And they're collecting grab samples of water that we're then sending to the Klamath Tribe's water quality lab, where they're doing analysis for things like nutrients and turbidity. We have suspended sediment concentration samples analyzed by the USGS labs. And those samples are all really important. They're telling us how much sediment is moving through the river, what kind of effects we can expect to see to fish based on how much sediment is in the river.
When all this mud gets washed out of the river, it's gonna be a free-flowing river, and hopefully by fall of this year, I'll be leaning over and maybe see a salmon or a steelhead swim by. So here's a pretty good illustration. So these are the SSC samples. This is Daggett Bridge where we're at. And the river looks really bad up here right now, but look how clear it is by the time it makes it down to Orleans.
It's also telling us how inputs of things like microcystin might be changing with the changes in the harmful algal blooms and what effects we can see on water quality from that. They're actually out sampling every other week for suspended sediment concentration, so a little bit more frequently, because we want to get a really clear picture of how much sediment is actually moving out of the reservoir and into the river. And that way we can get an estimate also of how far downstream that sediment is moving and what kind of impacts it's having in the lower reaches of the river.
We got methylmercury, nutrients, turbidity. Let me check the book here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay.
Today we're out installing water level loggers on some of our priority restoration tributaries. So these are tributaries that their confluences used to be underwater. They were under the reservoirs, but that we think are going to be really important for aquatic habitat. So this is the water level logger, which is taking pressure readings and temperature readings every 15 minutes. Put that one through the bottom. So right now we're at Beaver Creek. We're also going to be going to Jenny Creek and Camp and Scotch Creek. And we're installing these loggers to help kind of get a sense for what stream flow actually is in these tributaries, what kind of flow we're working with when we're doing revegetation. We're putting in large woody debris. We're doing restoration kind of in these zones that are now unearthed, that were once below the reservoirs, but now are going to be important fish habitat. They're going to be juvenile salmonid rearing habitat. They're going to be spawning habitat. And we want to make sure that we have the data we need to do the best restoration possible in these areas.